All right, so this is the previous quiz that you have done in the previous class, I believe, which is quiz number 11. Um, and I think you may have noticed the diagram that we have used in chapter 9 and 10 is very similar, just with some changes, but the question is different. Um, Meaning that in chapter 9, we ask for centroid or center of mass or center of gravity, while in the chapter 10 we ask for moment of inertia. Hopefully my voice can be heard, right? Okay, so this is for chapter 10, which is moment of inertia. And in this question, mm, okay, where is this? Oops. Mm, Okay, so in this question over here, so the question actually asks for you to answer both part A and part B. For part A, we have to compute moment of inertia of the area, the blue area here, about x-axis, and then you have to clearly state elements corresponding to equation used, and then show the steps, and then compute the moment of inertia about y-axis, right? So you have to calculate both. And the very first thing that should be very clear from the very beginning is the equation that you want to use and which element it corresponds to. Right? For example, for Ix, in terms of the integration equation will be integration of y square dA. This is for, where should I put it? I put it down here. This is for horizontal element, right? And if you want to use Ix equal to integration of dIx, this is for vertical element, right? So that is the thing, meaning that uh, which equation that you want to use and which elements, right? So this is going to give you both the same, which is Ix. Now, so in this case, of course, in the sense, it's easier normally to have, maybe I should use a different color. Normally, it's easier in this particular case before we go to the equation, right? Area that is connected to x-axis, normally the easier one, the shorter calculation one is the vertical element. So you may use this equation if you want. If you do this, then that is where what we derive using parallel access theorem, or even you derive from the beginning to get um, where to get this. So if this is the x-axis, and then the element is like this, and then if you have b and h, you will end up with Ix equal to 1 over 3 bh cubed, right? So when the situation is like this, where x-axis is here, and this is dx, and this is y, so when you replace h with y and b with dx, what you will get is dix, because it's differential, equal to 1 over 3 y cubed dx. Basically, we just rearrange the arrangement, right? It's basically like h cubed b and y cubed dx. So we'll get this the element, the, how to say this, the differential moment of inertia of that element. So once you establish this one, you just plug into here, right? And you are ready to integrate, meaning that Ix will be integration. So because we chop off like this, so meaning the first element is here, the last element is here. So you integrate from 0 to 4. So from 0 to 4, and then you just plug in dix, which is the whole thing here, 1 over 3 y cubed dx. And of course, you have to convert this y into in terms of x to integrate with respect to x. So using this one here, you will have, so y equal to 1 over 2x, right? So if you plug inside here, so if you do 0 for 1 over 3, you plug in, you'll have 1 over 2x, and then the whole thing cube. So you expand this 0 to 4, 1 over 3. So 1 over 2 power of 3 becomes 1 over 8, right? 2, 4, 8, right? Okay, and then you have x cubed there, dx. And the rest is just calculation, mathematical calculation, right? You have 1 over 24, and then you come x power, don't have space, right? But you know, x become power 4, so x to the power of 4, divide by 4, and then you include this limit for 0 to 4, and then you get a certain value. Now, if you do not want to use this, rather you want to use a horizontal element, which is this equation here, then you are free to do so. What color can I use here? Green, is it suitable? Okay, so meaning that you will use this element here. Oops, the horizontal element. So when you take out that horizontal element, if you bring it here, so this will be dy, but this whole thing is 4 minus y here, 4 minus x, right? So you have 4 minus x, so you get that one. So to get this dA is just straight away this multiplied by that one. So dA equal to 4 minus x times dy. It's just base times height, and then this is ready to plug in if you want to plug in straight away, right? So if you plug in straight away, you get ix equal to integration. Of course, when you do this, what you do is you chop like that. So the first element is 0 down here. Sorry, the maximum is limit at 2, so it's from 0 to 2. So you have y square. So you have y square, and then plug in dA, the whole thing here, 4 minus x dy. So of course you have to integrate with respect to y, so this x have to be converted. So from here you can get x equal to 2y. Is it x? Yep, x equal to 2y. So if you plug inside here, you get from 0 to 2 y square, 4 minus x become 2y, so 2y dy. So if you expand this, you get 0 to 2 4y squared minus 2y to power 4 dy. And the rest is just calculation. Where you get 4, then y power of 3 over 3 minus 2y to power of 5 over 5. Then you plug in, sorry, is this, why is it 4? This should be 3, right? Wait a minute. Okay, y square here, y, okay, yeah, sorry, that's my mistake there. So this should be y3. So when you integrate, it becomes y4. And then you put in the limit, you get the value. So both ways will give you the same answer for ix. So you do not need to repeat both things. I'm just showing what is possible to get for moment of inertia about x-axis, be it this element or this element. Both will give you the same answer. Of course, if you calculate to the end, you will have completed this part. But then you have to also calculate another one, which is moment about y-axis. So hopefully no question. If you have any question, please ask. Because I think I will have to erase this to calculate for IY. We don't have enough space in the screen here. Okay. So next we go to IY. Of course, for IY, then it is integration of x square dA. This is for a vertical element. If you want to use horizontal element, IY equal to integration of dIY. This is for horizontal element. So if you take vertical element, so it become like this. That's the easier vertical in terms of the area attached to the x-axis. And then this case, you'll get dx and y. right? So in that case, dA is simply y dx. From there, you plug in, so you get y equal to integration of from 0 to 4. So from 0 to 4, x square, and then you have y dx, and okay, I put that first, y dx, and then y dx, y is just, you can replace with this one, you plug in, so from 0 to 4 x square, and then you have 1 over 2 x dx. So you expand that, so 0 4 1 over 2 x cube dx, and the rest is just mechanical calculation of integrating this. You get 1 over 2 x to the power of 4, and then divide by 4, and then you have the limit of 0 to 4. You place it, you plug in, and then you get a certain value, so that is how you can get a y. Now, given that this is the shortest possible way, um we do not need to do this, because first we have to establish what is diy, and then you have something like 4 minus x or something, so that is beyond, or not really, yeah, to get diy for this one, it will take a long time, right? So I do not expect anyone who want to go through all this trouble, especially in the exam. So we just avoid this. Just use this easy calculation to get straight away moment about y-axis. All right, so that is the explanation in terms of the basic steps to compute for the previous quiz. So if there is any question, feel free to ask. Otherwise, I'll just stop sharing this first. All right, so there you go. The explanation for moment of inertia from integration in the shape, as you have covered in the previous quiz. Make sure you understand all of this, because as I have mentioned before, chapter 9 and 10 confirm will be in the final exam. Obviously, it might be either composite or integration for each chapter 9 10. So normally it's flipped. So it depends on the lecturer that do the make the question, but you have to know each of those, so that either way the question comes, you can answer this correctly, get the full marks. And because normally the easiest question to get full mark is chapter 9 and 10, because there's no trick there. It's very straightforward as long as you understand. All right, so any question? Otherwise, feel free to continue whatever you're doing, be it to this chapter or etc.